Deep within the chaotic heart of the Milky Way, in a place where stars gather like glittering bees and the supermassive black hole, Sagittarius A, exerts an inescapable grip, a cosmic drama is unfolding. Amid this gravitational frenzy, tangled magnetic fields and high-energy gas clouds create a volatile galactic cauldron. And threading through it all are mysterious, glowing structures, immense filaments made of spiraling charged particles that resemble skeletal bones stretched across the galaxy. One of these ancient structures, known as the snake, has just been struck with a blow that could only come from the cosmos's most extreme kind of traveler, a runaway pulsar. Prepare to dive into one of the most astonishing and jaw-dropping cosmic encounters ever observed. Picture this: a rogue pulsar, a dense, spinning remnant of a once mighty star, barreling through the Milky Way at incomprehensible speeds, crashing headlong into one of the galaxy's most mysterious and massive magnetic filaments. This filament, dramatically named the snake due to its sinuous structure, stretches an epic 230 light-years and has long stood as a symbol of galactic stability. But now it's been violently disturbed. The pulsar's brutal impact has created a stunning, unmistakable kink, warping this celestial structure and shattering the illusion of its tranquility. What was once seen as a static, enduring feature of our galaxy's core is now exposed as vulnerable, dynamic, and reactive. This event isn't just about a space object hitting another, it's a dramatic narrative of velocity, raw cosmic power, and magnetic mayhem. It forces us to rethink our understanding of how the inner machinery of our galaxy functions and reveals that even the most seemingly immovable parts of space are still dancing to the rhythm of astronomical chaos. These filaments are no ordinary threads of gas. They're channels of highly energized particles racing along intense magnetic field lines. As they move, they emit radio waves, signals that can be picked up by ultra-sensitive telescopes like South Africa's MeerKAT array and NASA's Chandra X-ray Observatory. The snake, one of the largest and brightest filaments near the galactic center, stretches across an astonishing 230 light-years. It's long, luminous, and until recently appeared relatively undisturbed. But new data reveals a different picture. This cosmic serpent has been twisted, bent, and fractured. Groundbreaking research recently published in the monthly notices of the Royal Astronomical Society has uncovered a dramatic explanation for the snake's warped and fractured form. This cosmic investigation, powered by a trio of cutting-edge observational giants, NASA's Chandra X-ray Observatory, the Very Large Array, VLA, and the MeerKAT radio telescope in South Africa, focused on a peculiar bend in the filament where its structure appears most violently distorted. There, nestled within the kink, scientists identified an intensely energetic, ultra-compact object that appeared to be the epicenter of the disruption. This object, designated G359.13142-0.2005 and more casually referred to as G359.13, is no ordinary celestial body. It is a pulsar, a breathtakingly dense, rapidly rotating neutron star left behind in the wake of a cataclysmic supernova explosion. Essentially, it's the stellar equivalent of a wrecking ball, its dense core spinning with terrifying velocity, radiating beams of energy, and barreling through space like a cannonball forged in the heart of a dying star. The moment it intersected with the snake, it became a destructive sculptor, reshaping this once serene filament with invisible forces of magnetism and motion. This discovery not only identifies the cause of the snake's fractures, but also deepens our appreciation of the chaos that rules the galactic center, where even ancient structures can be upended in a flash by a cosmic bullet, like G359.13. Pulsars are fascinating objects. Born from the explosive deaths of massive stars, they are neutron stars with magnetic fields so intense that they emit beams of radiation from their poles. When these beams sweep across Earth, they appear to blink on and off, like a cosmic lighthouse. But pulsars don't always stay put. The violent explosion that creates them can act like a cosmic slingshot, sending them hurtling through space at breakneck speeds. And that's exactly what happened here. G359.13 is traveling at a speed between 1 and 2 million miles per hour, so fast it could circle Earth nearly 80 times in 1 hour. When it slammed into the snake, it didn't just brush past, it crashed straight into it, distorting the magnetic field and injecting high-energy particles that lit up the filament in X-ray and radio wavelengths. It created a kink, a dramatic warp in the snake's smooth structure. Scientists believe the larger kink was formed from this direct collision, while a second, smaller kink was the result of shock waves from the impact. Think of it like a meteor plowing through an icy river, sending ripples and cracks far beyond the initial strike. The snake has long captivated astronomers as one of the most prominent and unusual filaments in the galactic center. Its immense length, brightness, and nearly symmetrical structure set it apart. But now, with this latest discovery, it's entering an entirely new realm of cosmic significance. What once appeared as a stable, serene stretch of charged particles has revealed itself to be a battlefield, scarred by a dramatic interstellar collision. Instead of being a relic of slow galactic processes, the snake now appears as a living testament to violent, high-speed encounters that can reshape the very fabric of magnetic structures in space. Researchers have described the snake's morphology as kinked, warped, and unmistakably fractured, and for good reason. The previously smooth and linear filament has been bent and twisted in ways that strongly suggest an external force acted upon it with tremendous energy. This force, the pulsar G359.13, barreled into the filament like a cosmic cannonball, sending shock waves rippling through the magnetic field lines. The brighter, glowing X-ray emissions that astronomers are detecting today are not random. They're signposts of the collision's epicenter, hotspots of energy where the pulsar's high-velocity impact continues to disrupt and rewire the magnetic environment. It's as if we're watching the filament's scars heal in real time, illuminated by the very energy that wounded it. What makes this even more thrilling is that the story is still unfolding, and we're only at the beginning of what could be a groundbreaking chapter in galactic exploration. Scientists aren't just stopping at this discovery, they're doubling down. They plan to monitor the snake and its mysterious interloper G359.13 with even more advanced and higher resolution imaging techniques. These future observations will focus on tracking the precise motion of the pulsar as it continues to race through space, potentially interacting with other magnetic structures along the way. But it doesn't stop there. Researchers will also map the subtle and not-so-subtle changes in the snake's physical structure over time, watching for new deformations or bursts of energy. This continuous monitoring could help determine whether these filaments are stable structures or dynamic entities that evolve in response to external influences like pulsars. Using next-generation observatories and computational simulations, scientists aim to peel back the layers of mystery surrounding the galactic center, unlocking answers to some of astronomy's most compelling questions. How do these massive filaments form? What roles do they play in shaping galactic evolution? Are interactions with fast-moving neutron stars like G359.13 more common than we think? Each new image, each data point, brings us closer to understanding the powerful invisible forces that shape not just the center of our galaxy, but potentially the cosmos itself. It's a thrilling frontier, and we're right on the edge of it. Still curious about what's unfolding 25,000 light-years away at the galaxy's bustling core? You're not alone. The universe is full of mysteries, and we're just beginning to scratch the surface. Hit that subscribe button to keep exploring the cosmos with us. Got questions, wild theories, or just want to geek out about pulsars? Drop a comment below. We'd love to hear your thoughts. And if this story gave you chills, don't forget to like this post and share it with your fellow stargazers. The Milky Way is alive with secrets waiting to be uncovered. Let's keep looking up together.